What's the binomial distribution self-quiz? A box holds 240 eggs. The probability that an egg is brown is 5% or 0.05 probability. Same thing. Find the expected number of brown, so A, find the expected number of brown eggs in the box. So remember, expected number, same thing as the same mean or average. They mean the exact same thing. So if we look at our formula sheet, and under binomial, mean or expected value is n times p. So that's all it is. So we're just going to do n times p. My n is right here, 240. My p is right there. So multiply them together, we get our answer. So 12. So there we go. Find the variance of the box. And then variance, that's also in your formula sheet. Right, variance is right here. And P1 minus C. Now remember, it's only works variance. It's only works with binomial variance. If I ask you variance and it's not a binomial question, do not use this formula. Use your calculator to find the standard deviation and then square it. So in this case, we have, and that is, right, variance equals n times p times 1 minus p, which would be 240 times 0.05 times 0.95. This was 12, these together times 0.95. It's like 11 point something. I was going to get my answer and times about 0.95. 11.4. So that's the variance. Now what's the standard deviation? Remember, that's on your formula sheet. We can check it, right? No standard deviation, not for this. So how do we find it? Remember, they are related. Variance and standard deviation are related. Variance is bigger. Since I have the variance, I can take the square root to find the standard deviation. So square root of 11.4. We'll actually find the answer. It's fine. Square root of the answer, 3.37. 36 3.38. Next, find the probability that there are 10 brown eggs in the box. So that's like saying exactly 10. So this is binomial PDF x equals 10. So my calculator. So second distribution, binomial PDF. I believe we have 240 eggs. Yep, 5%. So 240, 0.05, and then 10. So I get 0.106. So about 11% chance of getting exactly 10 eggs in the box. Find probability there's at least 15 brown eggs. So at least 15. So that's x is going to equal to 15. Right, at least 15 cookies or whatever. So that way, so that's pointing in the wrong direction. So that's that's 1 minus, it's pointing in the wrong direction. X is less than 15. Remember, point in the wrong direction, you gotta do 1 minus. When you do that, you lose or gain the sign, depending on what you have. It's the opposite of what you have. In this case, I have the sign, so I lose it. You can't put that in your calculator. You gotta do 1 minus. Gotta get the equal to sign back. So you go 1 down. You get that. So we're gonna plug this into our calculator with this being binomial CDF. So back to our calculator. Second distribution, binomial CDF. So trials, did I put 1 minus first? I meant to do 1 minus first. 1 minus. That, because sometimes you forget when you don't do it beforehand. You just put the answer down because you're so excited to get the answer. So second distribution, CDF, sorry. We have 240. I really always forget that. 0.04, 0.05, 5%, and then we're having 14. And we get 0.223. So that's the odds of getting at least 15 brown eggs in the box. That's a lot of brown eggs in the box. Found probably at less than 12 brown eggs in the box. So less than 12. Well, less than 12 now, that's almost good. It's pointing in the right direction, so I don't have to do 1 minus, but it doesn't have the sign, so I have to go 1 lower to get the sign. So that's what I'm putting in my calculator. Binomial CDF of that. Again, no CDF. No 1 minus. It was pointing in the right direction, just didn't have a line. So no line. So no 1 minus. I'm going to put second CDF. And then just 240, that, 11. Hit enter. Hit enter again. 0.459 sig figs. There we go. And the last one here, given that there's at least 12 brown eggs in the box, find the probability there is exactly 10 eggs in the box. So, given that question, IB's favorite thing in the world, so let's write it, probability that there is, given that there's 12 brown eggs, less than 12 brown eggs, find the probability that there's exactly 10 eggs. So something like that. Remember, we're just going to use our formula from the formula sheet. Since I have it, let's look at it. Given that I moved for no reason, right here, conditional probability. Hey, they changed it. Sorry, they changed the formula. So it's like the right formula, but they changed the way they written it like a couple of times. Oh, okay. So it's like this. That's a different formula. Okay. So, sorry about that. They did change that formula. Well, not the formula, but the way it's written. It used to be B given A, and now it's A given B. Anyway, so we have that, and then we're going to plug it in. So, again, notice this is like saying x equals 10, x is less than 12. So this is x equals 10, and x is less than 12. And then this is second term, which is x is less than 12. And we're looking for this part over here. I actually have the bottom, we did that. We just did that. Find probably that you're less than 12, so 0.456. And as I always say, the hardest part of this thing is figuring out what this guy is. What is equal to 10 and less than 12? So I like to draw a number line. Here's 10, equal to 10 is just that. Here's 12, less than 12 is an open circle going this way. Where do they overlap? They only overlap at one spot, and that's right here. So intersection of something that's equal to and less than or greater than is always the same thing. It's the number. It's x equals 10, which we did earlier. What's the probability that you're exactly 10? Right here. The exactly 12 is 0.106. So 0.106. Plug that into your calculator. So we're going to do 0.106 divided by 0.456. And I get 0.232. That's the answer. Now this would have been the extra credit I would have given. So it says effect little review of binomial expansion because they are kind of related. If you remember your binomial expansion, if I want to find x to the sixth term, how do I do this? Well, you always do the same way. You write down what you know. If I want to expand this, you always write the highest power, the power. You write the first term, and you write the second term. And then you go, okay, what do I want? They want x to the sixth. Well, here's my x. How do I make that a power of 6? Well, that means the power has to be a 3. Because remember, power to power you multiply. So this has to be a 3. So you get x to the 6. Well, if that's a 3, that opens up everything else, right? The power here and the power here have to add up to be the top number, which in this case is 7. So this has to be 4. If that's a 4, then this has to be a 4. And then all we gotta do is simplify it. 7c4, just Pascal's triangle, use your calculator for that. You'll use a formula. If you use your calculator, it'll be 7 math probability NCR 4 35. You can also use the formula to give you the formula sheet, which is right here, binomial coefficient, 7 factorial over 4 factorial. Just put the top one over the bottom one. That's all we do, and then subtract them, so 3 factorial. If you remember how to simplify factorials, you break up the top number, so it'll be 7 times 6 times 5 times 4. You stop once you get to the top, the highest number on the bottom, which is 4 in this case. So you always keep that the same. And then the smaller number you break up. So in this case, 3 is smaller, so 3 times 2 times 1. 4's cancel. 3 times 2 is the same thing as 6. So those cancel. Left with 7 times 5, which is 35. So that's how I do it by hand. I'll show you in your calculator. Either way works. And then here we gotta expand that. So distribute both. So I get 3 cubed, which is not 27. I'm gonna say 9. X to the 6. And then 1. Then 27 times 35, I don't know that. So maybe I could do all this on the calculator. And 945. So that's the answer. That's this little review.